Hello friends, so this video is on demand of the student on the topic derivation of phase rule. First we will see what is phase rule. If equilibrium of heterogeneous system is not affected by gravity or by electrical or magnetic forces, the number of degree of freedom, that is F, are related to the number of component and number of phases as F is equals to C minus P plus 2. The student, you have to remember this formula. F is equal to C minus P plus 2. So now we will see the derivation of this formula. How this formula is come, that is F is equals to C minus P plus 2. So for the derivation of this formula, we will consider the system. You can see in this diagram we have considered a system in which we consider C number of component, that is C1, C2, C3 up to C, and number of phases, that is in upward direction we have considered the number of phases, the horizontal lines separating the each phase, and we have given the name to each phase like alpha, beta, gamma, etc. up to p. So this is our system, that is our consideration for the derivation of phase rule. So the number of component are in horizontal, that is C1, C2 and up to C, and number of phases for that we go in upward direction, that is alpha, beta, gamma up to P. So to calculate the degree of freedom, the formula is F is equal to total number of variables minus number of variables already fixed. So if we want to calculate F, two values we must know. The first one is total number of variables and another one is number of variables already fixed. So first we will calculate total number of variables. For any system there is only one pressure and one temperature, hence these are two variables. Now for a system having C component, there are C minus 1 concentration term in each phase. So concentrate on this sentence, student. For a system, any system having C number of component, in each phase there will be C minus 1 concentration term for one phase. Means if we will consider alpha phase, in this phase there will be a C minus 1 concentration term, and we know that in this system we have considered P number of phases. So if we want to calculate total concentration term in this system, so we have to multiply C minus 1 into P. It is quite difficult to understand. For this we will consider a simple example, that is if one mango is of 2 rupees, so if we want 10 mangoes, for that we will calculate 10 into 2, like that. For one phase there is C minus 1 concentration term, so for P number of phases we have to multiply C minus 1 into P. So total number of concentration term in P phases is equal to P into C minus 1. But we know that there is already one pressure and one temperature term, so that is, these are two variables, so the total number of variables is equal to, this is also variable, so P into C minus 1 plus two number is came from, one is pressure and another is temperature, so this is the two variables, so total number of variables become P into C minus 1 plus 2. This is the total number of variables. Now we will calculate the number of variables already fixed. The number of variables already fixed, for this system, consider any system having three phases, and mu A, mu B and mu C are the chemical potential of these components in three phases. So there are two equations. Mu A is equals to mu B and mu B is equals to mu C. Means if we consider a three component system, three phase system, in that system we are getting two equations, that is mu A is equals to mu B and mu B is equals to mu C. So if we consider four phase system, then we will get the three equation. If we consider a five phase system, we will get the four equation. Likewise, this is the p phases system, hence we will get the p minus 1 equations for each component. P minus 1 equation for each component, but in this system we have c number of component. So for total number of system, the total number of variables become c into p minus 1. Student, I am repeating this. We will calculate number of fixed variable. So consider any three phase system in which mu A, mu B and mu C are the chemical potential. So for this system we will get the two equations, that is mu A is equals to mu B and mu B is equals to mu C. Means our system is three phase, for that we will get the two equation. Similarly, if we have the four phase system, we will get the three equation. If we have the five phase system, we will get the four equations. Similarly, in this system we have p phases, therefore we will get the p minus 1 equation for one component. But in this system we have the c number of component, therefore total number of variables is equals to c into p minus 1. So now for the formula of degree of freedom, total number of variable that we calculated and number of variable that we already fixed, that is also calculated. So these two values we will put in this formula. Therefore degrees of freedom f is equals to this p into c minus 1 plus 2, that is total number of variables, minus c into p minus 1, that is number of variables already fixed. This p is multiplied in this bracket and c is multiplied in this bracket, plus pc minus pc cancel out. This is c is plus term, so we will write it first, c minus p plus 2. This is nothing but the phase rule. You have to remember this formula, f is equals to p minus c minus p plus 2, where f is a degree of freedom, c is a number of component, p is a number of phases. Thank you.